Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS3501, Compiler Design, Unit 2, Topic Recursive Design Processor, Predictive Parser. Recursive Descent Parser. This parser uses a procedure for each non-terminal. The procedure looks at its input and decides which production to apply for its non-terminal. Terminals in the body of the production are matched to the input at the appropriate time, while non-terminals in the body result in calls to their procedure. General recursive design may require backtracking, that is, it may require repeated scans over the input. However, backtracking is rarely needed to pass programming language constructs. This is an example for recursive design parser. Consider the grammar S tends to CAD, A tends to ABA. Now we are going to construct a parse tree top down for the input string W equal to CAD. So from the starting grammar you are going to mention SCAD. For the A you have the grammar. For the A you are going to apply AB. Otherwise you can apply A also. This is an example for recursive design parser. Recursive design passes step 1. Initially create a tree with a single node labeled S and input pointer points to C. The input symbol of W expand the tree with the production of S. And input pointer points to C. The first symbol of W expand the tree with the production of S. Step 2. The leftmost leaf C matches the first symbol of W. So advance the input pointer to the second symbol of W, A, and consider the next leaf A. The second symbol A of W also matches with the second leaf of tree. So advance the input pointer to third symbol of WD. But the third leaf of tree is B, which does not match with the input symbol D. First and follow. First is defined as a set of terminals that begin string derived from alpha. If A tends to epsilon, then epsilon is also in a first of alpha. If predictive parser, when we have A tends to alpha or beta, if first of alpha and first of beta are disjoint sets, then we can select appropriate A production by looking at the next input. Follow of A for any non-terminal A is set of terminals A that can appear immediately after A in some sentinel form. Algorithm to compute first of X and follow. To compute first of X for all grammar symbols X, apply the following rules until no more terminals or epsilon can be added to my first set. If X is a terminal, then first of X is equal to X. If X is a non-terminal and X tends to Y1, Y2, dot or Yk is a production, for some k greater than or equal to 1, then place A in first of X. If for some I A is in first of Y1 and epsilon is all of first of Y1 dot or first of Yi minus 1. That is Y1 tends to Yi minus 1 belongs to epsilon. For all j equal to 1 to dot or k, then add epsilon to first of X. For example, everything is first of Y1 is surely in first of X. If Y1 does not derive epsilon, then we add nothing more to first of X. If X tends to epsilon is a production, then add epsilon to first of X. Algorithm to compute follow of A. To compute follow of A for all non-terminals, apply the following rules until nothing can be added to any follow set. Place dollar in follow of S where S is the start symbol and dollar is the input right end marker. If there is a production A tends to alpha, B, beta, then everything is first of beta, execute alpha is in follow of B. If there is a production A tends to alpha B or a production A tends to alpha B beta where first of beta contains epsilon, then everything in follow of A is in follow of B. Example to compute first and follow for the given grammar, non-left recursive grammar. This is the given grammar. For this grammar, you are going to find out the first and follow. First of F equal to first of T equal to first of E. That is open bracket and ID. To see why, know that the two productions for F have bodies that start with these two terminal symbols ID and the left parenthesis. T has only one production and its body starts with F. Since F does not derive epsilon, first of T must be the same as first of F. The same argument covers first of E. First of E dash equal to plus comma epsilon. The reason is that one of the two productions for E dash has a body that begins with the terminal plus and the other body is epsilon. Whenever a non-terminal derives epsilon, we place epsilon in first for that non-terminal. First of T dash equal to asterisk comma T. The reason is analogous to that for first of E dash. Follow of E equal to follow of E dash equal to close bracket dollar. Since E is the start symbol, follow of E must contain dollar. The production body of E explains why the right parenthesis is in follow of E. For E dash, note that this non-terminal appears only at the ends of bodies of E productions. Thus, follow of E dash must be the same as follow of E. Follow of T equal to follow of T dash equal to plus close bracket dollar. Notice that T appears in bodies only followed by E dash. Thus, everything except epsilon that is in first of E dash must be in follow of T. That explains the symbol plus. Predictive parser. Predictive parsing is a special case of recursive descent parsing where no backtracking is required. The key problem of predicting parser is to determine the production to be applied for a non-terminal in case of alternatives. This parser looks up the production in parsing table. The table-driven predictive parser has an input buffer stack, a parsing table, and an output screen. Transition diagram for predictive parser. Transition diagram are useful for visualizing predicting parser. For example, transition diagram for the non-terminals E and E dash of the given grammar. To construct the transition diagram from a grammar, first eliminate left recursion and then left factor the grammar. Transition diagram for predictive parser differ from those for lexical analyzers. Parsers have one diagram for each non-terminal. The labels of edges can be tokens or non-terminals. A transition on a token or terminal means that we take the transition, it have token, that is the next input symbol. This is a transition diagram for the given grammar. Predictive parsing program. The predictive parser has an input, a stack, a parsing table, and the output. Input, it contains the string to be passed followed by right and marker dollar. Stack contains a sequence of grammar symbols preceded by dollar. The bottom of stack marker. Initially, the stack contains the start symbol of the grammar preceded by dollar. Parsing table, it is a two-dimensional array M of A, A where A is a non-terminal and A small a is a terminal or dollar. Output gives the output whether the string is valid or not. Thank you.